Hello everyone, my name is Sabina Gera and I will briefly tell you something about the topic chemical, toxic and radioactive properties of depleted uranium, which is processed within the Module 2. Actually, in this part of the Module 2, I will briefly say something about the toxic properties of depleted uranium. So, we will have a look at the toxicity of uranium and uranium salts, depleted uranium and the public health. What is the toxicity of uranium and uranium salts? Uranium, like all heavy metals, can be toxic. Its chemical toxicity is less than that of other heavy metals, including arsenic and mercury. Naturally occurring uranium is composed of two primary isotopes, uranium-235 and uranium-238. These elements are present in nearly all rock, soil, and water. However, uranium-238 is the most abundant form in the environment. Uranium-235 can be concentrated through a process called enrichment, which makes it suitable for use in nuclear reactors. Due to the nature of uranium decay involving alpha particles, external exposure to uranium is not as hazardous as exposure to other radioactive elements. This is because the skin effectively blocks the alpha particles, reducing the likelihood of internal exposure. Nevertheless, ingestion of high concentration of uranium can result in significant adverse health effects, including the development of cancer in the bone or liver. Inhalation of substantial quantities of uranium can result in the development of lung cancer due to the inhalation of alpha particles. As an environmental contaminant, depleted uranium mostly frequently occurs in the form of the metal itself, as well as a number of solid oxides. These may include those resulting from the oxidation of the metal, those who derive from the hydrolysis of uranium hexafluoride that has been accidentally released into the environment, and those formed through the neutralization of acidic industrial wastes that contain dissolved depleted uranium. Additionally, it can occur as soluble aqueous species, principally the uranyl ion, or as a number of insoluble and sparingly soluble species, including mineral forms that have arisen as a result of uranium's complex environmental. Additionally, uranium is a toxic chemical. Ingestion of uranium can cause kidney damage from its chemical properties at an earlier stage than cancer of the bone or liver would result from its radioactive active properties. The Earth crust contains different types of uranium ores. Uranium is predominantly present in the environment as a uranium oxide, most commonly in the form of urine dioxide, but occasionally as urine trioxide. Depleted uranium can exist in any chemical form in which uranium occurs. The primary sources of radiation exposure are groundwater, mining, phosphate fertilizers, nuclear facilities, and military activities. Individuals who are exposed to elevated levels of radiation may be at an increased risk of developing cancer, particularly leukemia. A remark will be made regarding the depleted uranium and public health. A significant health hazard is associated with the use of depleted uranium. Depleted uranium is a byproduct of natural uranium that has undergone enrichment and extraction of uranium-235. It is used to provide fuel for nuclear power plants and to charge nuclear weapons. The primary route of exposure to depleted uranium is through inhalation of depleted uranium, or that can be from the distinct sources. The initial source of exposure is the result of contact with the naturally occurring depleted uranium in the environment. The second source of exposure is attributable to the use of depleted uranium munitions. In the long term, the exposure pathways that become of greater significance are ingestion of depleted uranium incorporated in drinking water and the food chain through migration from the soil or direct deposition on vegetation. In the event of contamination of drinking water or food supplies with depleted uranium, ingestion can occur. The ingestion of soil is considered as a potential significant pathway. It is unlikely that direct contact of depleted uranium metal with the skin, even for several weeks, will result in radiation-induced erythema or other short-term effects. Depleted uranium particles and oxides retained in the body have different solubilities. Once absorbed in the bloodstream, uranium circulates as the uranyl ion, forming uranium carbonate and uranium albumin complexes. About 19% of a single uranium exposure is renally eliminated in the first 24 hours. The remaining 10% is rapidly redistributed to the bones and other organs. 66% of the total uranium body burden resides in the skeleton, where the uranyl ion co-deposits with the calcium. The average human body contains about 100 micrograms of uranium. Thank you for your attention.